Hello all. So in this lecture, we'll see what is stationarity. So a stationary series is one whose statistical properties such as mean, variance, covariance, and standard deviation do not vary with time, or this stats properties are not a function of time. In other words, what we want is stationarity in time series also mean that there is no trend, there is no season also. So just now we saw that we'll try to capture trend and season. The reason we wanted to capture that is if there is a trend or there is a season um, in our time series data, then our predictions will be very way off the chart. Right, you'll not do well with the predictions or forecasting. So so what we need is we actually need this stationary kind of data that it has constant mean, constant variance, and constant covariance also. So there is, like, I'll give you some visual part. Like, let's say for example this B chart, right? So B chart is having a little bit around, it's going around some amount of outliers are also there, that is okay, but you can see the mean is not changing over time, like it is almost in a same range, and the variance is also very low, like it has to be like uh, it is here 0 and it is toggling around it, okay. But if you see let's say this data below that, you can see here the mean was some around 100 300, and then it dropped off to around 100, right? So I mean the the value dropped off to around 100. So if you try to get mean of this lower values, only this lower values, then this lower value have average of very low number, right? It will not be even close to 300. But if you take average of this upwards value in the chart, the top values, then it will be around 300, right? So this is what constant mean looks like, and variance is like it should not vary too much, like it should not change in that way. And similarly there is like it should not have a covariance also. So we'll see what is covariance. But um, uh, so how will um, I mean there okay, what we have to do is like what are visual signs of non-stationarity. We'll first look that. So if there is a clear upwards or downward movement over time, the mean is not constant, right? That's what it means. A pattern that repeats at a regular interval, something that is seasonality, right? So if you see a pattern in anything which is repeating at a regular interval, yearly, monthly, weekly, then that has seasonality, right? So that is also not stationary data, non-stationary data. Now varying varies, the spread of data increase or decrease over time, making the series appear wider or narrower. If you have this kind of in the plot, then you can say that is also non-stationary. So if you see this all thing, any of this thing, then you will definitely know that this is not a stationary data. So we need a stationary data to make a prediction, and we are most likely to get a non-stationary data, right? Now let's see a few of this chart what we have here. So let's say for A has a trend, right? So you can see it's going from here to upwards. So you can say this is not going to be a stationary data, right? This is a non-stationary. A is non-stationary. B is varying around same point, and the variance is also small, so it could be a stationary data. Now here you can see the mean was around 5. Like mean means, you can say, and what I'm thinking is that around this point, few points if I take and add them and divide by whatever number I got, so average of this values will be around 5k. Average of this value will be around, let's say, 3500, and similarly average around here will be different, right? So if it is varying too much, then it is also again um, not a stationary data, right? And then similarly here I can see maybe this might comes under my thing that okay, it is having a around like 50 or 60 mean, and it is just varying too much, but maybe it could come under, okay. So it is like maybe and possibility will be there. So we'll see what we have to do for that also. But as of now, just visually if you wanted to identify this downtrend, so not as stationary. This might look like a stationary data. It's in the range and going around, but it has very high values. It's going like 7,000, 75,000 to 1 lakh, right? So the change in value is too much, so maybe due to that it's not stationary. Here you can see the data is going in some patterns and all, then it could be again stationary, non-stationary, right? So that way you can actually identify by seeing the chart that is it having a trend, or is it there a pattern in the data, or is data point varying too much. So all these things you can visually analyze and say this is stationary data or not. Okay. Now let's say, just imagine I couldn't able to identify this thing using charts. So what should I do? So there are two tests that we have to do. One is called ADF test and one is called KPSS test. Now what this tests are, how they do mathematically, that you don't have to worry about. We'll use some library to do that test, and we'll get the results out of it. So what you need to know is that in ADFS, null hypothesis is that series is non-stationary, right? And alternative series is stationary. So if we get a p-value of less than this value, then only we can say that series is stationary. Now, exactly opposite to ADF test is KPSS test. What it says, it's null hypothesis. The series is trend stationary, right? So or series is stationary, right? So here we can see that was a alternate, but it is here is a null hypothesis. And then again another is series is a non-stationary, it's alternate hypothesis. So in this case, what we want p value to be higher than this value 0.05 to say that uh, it's a stationary, right? If it goes less than 0.05 p value, then it will become non-stationary. The alternate hypothesis will get proved, right? Now what we'll do, again we'll import this. We'll take this data and here I have my passenger data, which has every component. So earlier the initial thing you can do first is you can do decomposition of that, right? So we saw in the last lecture how to decomposition. Then you once you have decomposition, you look at to it what trend is there or not. So we can see trend was there, right? So everything was there. Like, so trend is there, right? Kind of. So using this also you can say that this data is not going to be stationary, right? So it's a non-stationary data. But even though, like, if you don't get it, you can come here and do the ADF test, right? So ADF test is like AD Fuller you have to import from stats model, and against the AD Fuller you have to give your data, and you can kind of ignore this auto lag or something you have to keep. Okay. Now what it will is going to give you is it is going to give you some statistics of the AD Fuller test. And what important thing we have to see is we just have to see the p value, right? So here you can see it's a p value is 0.99. So what we saw for AD Fuller test, that the p value, if it comes below 0.05, then only we can take it as a stationary, right? But it is going very high value, so it is like in 0.99, right? So it is almost opposite to that, and that's why we can say that this is a non-stationary data. Now similarly we can do same thing with the KPSS, that we import KPSS, we give this passenger, and again you can ignore this, you just have to keep this, make sure you keep this way, and you get all this value. And again if we look at the p value, it is very small, like 0.01. So in this case we want higher, right, to say that it is a stationary data, but it is not higher than 0.05, right? Now okay, yeah, so same thing, just whatever he had done is it's just in the form function here. Okay, if you wanted to put it as a make it as a function and you wanted to print that, you can do that also. So you know it's easier to call this thing, like if you write all this thing again and again, instead of that you can create this thing, give a time series data like y, this our df passenger, and it will do the KPSS test for you. Similar thing you can create for ADF test also, if you wanted to do the multiple time the testing of same thing, right? Now what we can analyze from the data. If let's say both of them, ADF and KPSS, tells that concludes that given series is stationary, then series is stationary. If both of the test concludes that it's a non-stationary, then series is non-stationary. Up till it's a very clear. But what if both of them starts concluding opposite way? Like ADF concludes it's a non-stationary, but KPSS says it's a stationary, right? So that could happen. So what does it mean? It means that to make the series strictly stationary, we need to remove the trend in this case. So if you earlier we saw how to get trend component and seasonality component using classical decomposition, right? So using decomposition you can get this trend, and if we remove that, right, if we make the series detrended, that will become stationary. um, like we have to check it, it's not like always we will be able to do that, always we will be able to make just using removing this, but you will be able to make it stationary data. Again, like if ADF concludes stationary and KPSS concludes non-stationary, then series is um, different stationary. It makes like differencing is to be used to make series stationary. So what is differencing we'll see in the next lecture, but as of now just see that if you get this and you wanted to make it as stationary, you have to do the differencing, okay, to get it as stationary. Now okay, same thing. um, so as of now I just given you example of it, but don't worry too much about it. So what we are doing is like we have this data again. Now if you fit a model on it, like linear regression fitting x and y, and you get some trend, right? So you get this as a trend, you write it as a trend, and I'm saying that how to do detrending, right? So this is a way you can do the detrending, that you remove the predictions from the y. So y was this passenger value, you remove this predictions from that, right? So this model has learned, or the model prediction has learned what is trend is. So you can see linear regression is going to be a line, straight line, that is a trend. Now that trend I have to remove, so that's what I am doing here. And if I do again plot this data, you can see it is very it has come under very narrow range, like it is not going upward, and it is worrying too much. So that's why maybe it will not pass the ADF or KPSS test, but it is at least in a it's not trending now, right? Now again you can do the same AD Fuller test and KPSS test. If you do that, uh, uh, okay, so basically this is just a function I have written, um, where if it is non-stationary it will print. It's just whatever we did earlier. It was very difficult to write a code of each of them, like you have to write all of this thing by yourself. But what you can do is you can, if you write all of this um, thing, AD Fuller test passenger, and then whatever detrended one we are testing on that also, right? So AD Fuller, then DF detrended, I have stored it here, and we are doing that. Same thing we are doing for KPSS test also, and it will give you printing of all this thing, right? So it's just a better representation of what we did earlier, and plus we are doing testing on my detrended one also, right? So what results we get is, the result we get is ADF is saying that original series was non-stationary, and KPSS was also telling that original series was stationary, right? So this is how we got result in this. So here my p value is coming out to be 1, right? 0.1. It should be greater than 0.05. That's what we discussed here, that it should be greater than and it is greater than 0.05, right? So that's why it's stationary. Now ADF, we are what we are doing is we are detrending it and then finding it. So again we are getting ADF is saying it is non-stationary, but KPS is saying it is a stationary, right? So now here again, like we had different opinion earlier, again we are also getting different opinion. So just retrending will not work. Maybe you have to do differencing also. So just now we saw what is some, like I just discussed what is referencing. So maybe you need to do differencing after that. So all this EDAs you have to do based on this value. So this IDF and KPSS test will be very useful to define what like what kind of EDA you have to choose, right? So in next lecture, we will actually cover what is how to make data stationary, right? So making the data stationary, that's what we'll cover in the next class. Thank you.